Welcome to JavaScript land. We are going to be taking a tour of this a vast new language. We're going to start off slow, obviously. We're going to talk a little bit about get a brief introduction to JavaScript, get some history. That's really what this first lecture is going to focus on. We're going to talk a little bit about just how did JavaScript come to be? What purpose does it serve? It does a lot of things for us, and principally does three things for us, and we're going to see what those are. And basically this whole week we're just going to learn what those three things are. Most of the actual JavaScript content is actually just done by Thursday, actually. You'll do a little bit of Rails on Friday, but for the most part, we're actually going to speed through the basics of JavaScript. After the code challenge, we'll get a little bit more in depth and learn a little bit more about how JavaScript works under the hood and find out some cool patterns. But for now, the basics of JavaScript, we're going to learn in the next 4 days. Cool. Now, has everybody noticed what bot is? Yes, good, nice. So basically, I'll go over these at the beginning of every lecture. Talk a little bit about just what are we going to be talking about? What are you going to be able to do and to discuss, hopefully, by the end of the lecture. So, in particular, today we're going to talk, as I said, the history of JavaScript. We're going to talk a little bit about what exactly JS does for us and why do we need it and why is it so powerful. We'll talk a little bit about the relationship of HTML, which you've already worked with, and JavaScript. We'll also, getting a little bit more technical, we'll talk a little bit about how JS is actually loaded into an HTML page. And then we'll talk about some of the basic data types and data structures in JavaScript, because that's obviously fundamentally important to using a language. And then this is going to be very new, is the idea of pass by value versus pass by reference. Right? This is something that we're going to explore, and you're going to see as being a unique and kind of interesting thing in JavaScript. It's going to allow us. It has there are some things that are weird about it, but there are actually some really cool things about pass by reference that's going to make JavaScript super powerful. Cool. Right. Any questions thus far? Cool. So. Ignore this for now. I'm going to show you what this is at the end of the lecture. But basically, talking a little bit about the history of JavaScript. JavaScript is a fascinating language. It was built in 10 days by this guy named Brendan Eich in 1995. That dude worked for Netscape, and it was really kind of not a well-celebrated language when it first came out. Obviously, if you build a language in 10 days, people are going to be like, why am I supposed to use that? But it actually conferred some really interesting abilities. And it's actually because JavaScript is so powerful that the internet is the way that it is today. So it is one of those really foundational language, especially in sort of this particular field of web development. And it has since branched out and become a very highly respected language. It is now a backend language. It's not just something you use on the web page. It's actually something you have people actually program in nowadays. And it's super cool. So to understand a little bit about why, what exactly was the necessity for JavaScript, why did Brendan Eich create this whole language? You have to think back to, does anybody around the time of AOL, or at least getting mail from AOL, right? The classic you've got mail type thing, right? Yeah, and AIM and stuff like that. Yeah. So one of the weird things about that time, in that time of the internet, was that you didn't really have the ability to put stuff on the screen. Every time that you wanted information, you would have to refresh the page, right? Now, you've already seen this in your Rails projects, right? Because what does your Rails backend actually serve to your browser? Let's say I make a GET request to localhost 3000/puppies, right? Which is the index route for puppies. What is the server actually returning to me? I'm sorry? A view. And in what format is it in? HTML, right? So the main thing was that it would just return to you some HTML page to show. And what that would look like is as far as request response cycle, it might look a bit if I can find a picture. No. I had it here. Now it's gone. Oh, it's right there. Okay, cool. Here's your browser. And this is still fundamentally the way the internet works. But basically, every time you wanted a page, you would have to make a request to the server, and then the server would return to you HTML to display, right? Oh, great. Is that a band?
Environmental fuel possession.
Okay. It's okay. All right, let's come back. Okay, so the idea would be that like this thing returns to you HTML. That's how your Rails servers have worked thus far. And if you wanted to change the page, you had to see if there were changes, you'd have to refresh the page, right? This is like a big thing that I'm sure was like a limitation as far as in building your Rails apps, is that like every time you wanted to do even a slight change on the page, you would have to like send a whole request and get a slightly different page back, right? And this is why, for instance, like when you got your mail, it wasn't live. You couldn't see that you were just getting new emails. Gmail nowadays has that ability. When you get a new email, it will just tell you, hey, you have a new email, right? Like a little number will tick up, and you will have a new unread email just appear in your inbox, right? What allows us to do that is JavaScript. The best illustration of like that power is to actually look at something. Do you guys remember MapQuest? Yeah, MapQuest. Yeah, it was like the map on the internet before Google Maps, right? And it looked like where is it? No, yeah, it looked like this, right? It was pretty bad, but like it was pretty revolutionary at the time, right? You had a map and you had all these buttons and like north, like you could go different directions. The way that this worked was that whenever you click, like for instance, north up here, what would end up happening was that it would refresh the page and it would give you a picture that was moved up slightly, right? So the idea would be that like, if you're on here and you wanted to move north, clicking here would send a GET request to coordinates just moved up a little bit, and it would get you an entire page again. It would serve you an entire HTML page, right? It was clunky, but it worked, right? One of the things that one of the reasons that MapQuest like met its demise was actually the introduction of Google Maps, right? Google Maps actually blew this out of the water for a very, very simple reason. Here's Google Maps, right? If I'm on here, I can actually just scroll up, and what do you notice happens? Yeah. You notice all these like empty spots just sort of fill in. Actually, if I go fast enough, what can I? Man, Google too fast. Internet too fast. There. You see that? You see those like empty tiles, right? The idea was that like none of that stuff was there when I first loaded the page, but the idea was that like when I actually moved the map, without having to fetch for an entirely new HTML page, it got new data and also displayed it on the page, right? Three things are actually happening there. It's listening for me moving, or like basically moving the map. It's getting information from the server, and then it's using JavaScript to actually load it onto the page. Actually, technically, JavaScript is being used for all three of those things, right? And that's principally that's actually the thing that JavaScript is going to give us, is the ability to do those three things. I'm going to talk about that more in a second. But does everybody see why this would blow MapQuest out of the water, right? Just like really dynamic information, just like you don't have to refresh, you don't have to reload all these like ads on the side, right? Like, yeah, and it's like substantially faster. You don't have to get all this information. You just need the new information that you're getting from the server. What's that?
What do you mean when you say that is listening?
I'm going to talk about that in a second. So like the best illustration of that is actually here. Does everybody know this Twitter? Yeah, Coffee Debt, yes. So one thing in particular is like, I'm going to open this up. Does everybody know what this is, by the way? Yeah, this is your console, your DevTools. I'm going to go into the network tab, and I'm just going to show you some stuff. So I'm going to refresh the page and take a look at all these things that are loaded. Some of them is the HTML for the page. There's other things like all these pictures and images are downloaded from somewhere on the internet, and basically all of these things right here are that information. So this is everything that loads on the initial render. So I'm going to clear this for now, but take a look at this. You got to look through it. It's a fascinating. It's Coffee Debt. You just got to read it. It's interesting. So take a look at this. Take a look. You see? Does everybody see the scroll bar right there? Right. Notice what happens when I hit the bottom. Yeah, what happened there? Take a look at the scroll bar. And do you see it right there when I got to the bottom? Like at the very bottom of it, you see that loader? You notice I can just keep scrolling forever, right? The interesting thing about this is that if you notice in my network tab, if I clear this again, look at what happens when oh god. Look at what happens when I hit the bottom. Oh, clear that too. See this? Right? This is actually an outgoing request, and that's the status code 200. The idea was that like what actually happens is that on this page, the page is actually listening for me to actually scroll to the bottom of the page, right? When I hit the bottom of the page, what it does is it sends a request for more information, and then it puts it on the page for you to see, right? Three things that are happening. One, the code is listening for stuff for like the user to interact with the page in some way. In this particular case, it's listening for my scrolling. Two, it's fetching information from some server somewhere. And three, it's loading it onto the page for display purposes, right? And these are the principal like three kind of like pillars of JavaScript. Three powers of JavaScript. One, the ability to react to user interaction, right? Maybe clicks, scrolls, key presses, hovers, right, et cetera, right? Two, the ability to add stuff to the page. And three, the ability to fetch more information, make requests. Cool. And over the course of this week, we're actually going to see all three of these things in kind of like isolated bits. We're first going to like look a little bit, we're going to figure out like how this works, adding stuff to the page. And then we'll talk about user interaction. That's actually all tomorrow. And on Thursday, we'll talk a little bit about just like how do we get like more information. That's when we actually start getting into making requests, right? But basically, we'll cover all three of these things before the end of the week. Questions thus far about just like the overall, just like JavaScript and its abilities? What you're going to find is that you're going to be able to make your pages a lot more interactive. I'm sure before, like the best you had in Rails was links, right? And the links could take you to another page. But now you're going to have the ability to do a whole bunch of stuff, right? Interact with the page. Let your users interact with the page in a whole bunch of different ways. And that's going to be that's the super powerful thing about JavaScript, which is kind of fun about it. Cool. I guess one other little thing, just because like you'll see this often, is I'm going to talk a little bit about like what we call ECMAScript. Has everyone seen this? ES whatever, ES 2015, ES 6, anything like that? It's okay if you haven't. It's fine. But basically, to get into context, we're actually, when we use JavaScript, we're actually using technically what we call ECMAScript. To understand why this even like came into play is to understand this time in the history of the internet called the browser wars. It's a very dramatic name, but it's interesting. So one of the things about like JavaScript was that in the beginning nobody really respected it. But then it soon became very popular because it gave you the ability to do all that stuff, right? And because it was built in 10 days, everybody had their own, like, they were like, oh, we can totally like edit it this way and make it do this and make it do that and make it do some crazy stuff. And what ended up happening was that every browser, there was a time where every browser that existed had a different version of JavaScript, just entirely different, right? The browser wars were actually started because of this. Does everybody remember Netscape and stuff like this? Like Netscape Navigator, Internet Explorer still existed, was in existence back then. There were a bunch of other browsers, and every single one of them had their own JavaScript, and they all started competing for which one was going to be like the best, right?
So then why did Netscape lose?
I don't actually know. I feel like there's business things associated with that, but I'm not sure. I don't think it's like a tech thing that they lost. I think they got absorbed by someone. I don't know, actually. Yeah, probably something like that. But basically, what ended up happening was this. everybody had different versions of JavaScript, and this wasn't good for anybody. It wasn't good for developers, nor was it good for like common users. The reason why was because imagine you're a developer, and your company builds your website for like Netscape. Since the version of JavaScript on Netscape is different than that on Internet Explorer, your website does not work on Internet Explorer, at least not properly, right? So what ends up happening is that like you at the bottom of your web page have to put like a little thing that says works best in Netscape Navigator. And in order to use the internet properly, you actually ended up having to like every user had to have all the browsers installed so that like, oh, this page doesn't work properly in Netscape, so let me switch over to Internet Explorer, right? And it started this huge competition between them, like who's going to have the actual right JavaScript, et cetera, hence the browser wars, right? Just like most wars, they ended in a convention. This war was ended in particularly the meeting of this like group called ECMA, the European Computer Manufacturers Association. And what they decided was that we're going to produce one standardized version of JavaScript that every browser will use, every single one. And we will be the society that decides what the canonical JavaScript is going to be. And that's what ECMAScript actually is. That's why when I say like we don't really use JavaScript, we actually use ECMAScript. That's actually what that means. We call it JavaScript because that's a language, but ECMAScript is actually the decided upon canonical version of JavaScript that like everybody agrees to use, right? Now ECMA on occasion publishes like updates. Basically they were kind of like it's very much the same. There's like ES1, ES2, ES3, ES4 and ES5. Now we're actually on ES7, and I think they're proposing changes for ES8, or it might be we're at 8 and they're proposing changes for 9. I don't know. But the idea is that like it changes pretty frequently. ES7 is like relatively new and it has like new features. But the idea is that like ECMA is actually the society that's actually, or the group, I don't want to call society, is the group that is deciding like what features are going to be like usable in all versions of JavaScript everywhere. Cool. Right now, we're going to be focusing on like ES5 syntax because like that was JavaScript for most of its life. ES6 was introduced like only a few years ago, and it had some cool updates. We're actually going to see those some of those syntactical upgrades later in the mod, at the end of the mod. But for now, we're actually going to be learning technically ES5, and we're going to focus on that. There will be some ES6 things that will sneak in here and there, but like for the most part, it's pretty much like unchanged. JavaScript is like, as a language, functions very similarly to how it did in the beginning, but with some nice little upgrades that make coding a little bit easier. Cool. Any questions on ECMA? Or just like that whole history?
Are they still like a entity that decides?
Yes.
Do other languages have, like, how do you have agreed-upon versions of like?
Usually there's like one like controlling like board that actually like says what's going to go into the language. They're usually like professionals in the field, and like they like convene and they like talk about like, hey, we're noticing that like this is a problem, or there's like an efficiency thing here, or we think that a lot of people are using the language in this way, so we might want to adapt the language around that. So actually, yes, every language actually has that. They decide what are going to be the canonical features of the language. JavaScript was a little bit more dramatic because like it was so involved with like business and the internet, and also because it was so loose as a language when it first started that it was just such wildly different versions of it, that it, like the whole browser wars was like actually like a big thing. But other languages do also have the societies. They're just like a little bit like more like low key. Yeah.
And does it, like, whatever version people are using, whatever the latest version is, like, there aren't drastic differences as much as it was from like 4 to 5?
Yeah. I think the idea is that like there are slightly different versions of JavaScript, but like I think basically everybody uses one of the ECMA scripts. I think the minimum version that like literally every browser uses is ES5, which is why we teach you ES5. But technically speaking, like most browsers, like most modern browsers, will use the most up-to-date versions of ES. There are some exceptions, like there's some interesting things, like Google Chrome is sometimes like way ahead of everyone else, so they have like features that don't exist like in other browsers yet, because they start experimenting with them. But the base language is still the same. So you shouldn't really like run into compatibility issues with your code anymore. Cool. Maybe now, but it was originally it was by Europeans who decided this. Yeah. Any questions? Okay, cool. Cool. So that's JavaScript. That's like the history of it. Now it's time to dive a little bit more into like technical stuff. If you're ready for that, right? So this is going to be pretty straightforward. Nothing should be too crazy until we get to pass by reference. But I want to talk a little bit about like some of these data types. So some of these are data types, some of them are data structures, principally object. But we'll talk about the first 6. I'm actually going to gloss over symbol. I'm actually just going to ask you to ignore that. Basically, I'll tell you what it's for, but we don't ever use it. A symbol, you saw them in Ruby, and I believe they have a similar purpose in JavaScript, but they're basically used under the hood for basic key value pairs for objects, for like hashes, right? This we don't ever use ourselves. If you're curious to go on a deep dive on like how like hashes, or we call them objects in JavaScript, how they work in JavaScript, like you can look up like how symbols work. But for the most part, you should know it's there, but you don't ever really use it. Cool. So I'm just gonna gloss over that and jump straight into like undefined and null, right? Does anybody recognize these two, or like have any like parallels to Ruby? They're both falsy, right? We'll talk about that in a second. Anything else? Yeah, like basically nil. It's like null is your new nil. They kind of serve the same purpose. Undefined is kind of new to you. It's as a data type. It's actually kind of interesting, and it's more semantic than anything else. It's not really like, it doesn't really like have it's not that much different from undefined. I'm going to talk about this in a second, but let me just show you. So let's say that we make a variable, which in JavaScript we can start by doing this. Like that, right? You can make a variable like that. But one of the interesting things is that you can actually make variables without giving them a value, like this. I'm sorry. I want to talk about this later, because like I'm going to talk about this in the later lecture, right? So we don't actually use var anymore, but I'm going to talk about like why. But for now, I will just show you this, right? Just because like the differences in let and const are a little bit just too much for this particular lecture. So I'll talk about it later, right? But let's look at this. So this is a variable declaration, and this is also a variable declaration, but with no assignment. Now the value of beef here is undefined. Can anyone like figure out like what was the reasoning behind that? Like what was the idea behind like if you don't give a variable a value, why is it undefined?
Because it exists.
Yeah, because it what?
Because it exists because you declare it.
It exists, but
But you didn't assign it.
I didn't assign anything. It doesn't have a value, right? So the developers, the people who made JavaScript were just like, let's just keep it simple, right? If you create a variable but don't give it a value, it is just undefined. You haven't given it a definition. So that's what really undefined means, right? However, when you do something like this, like, right? Both of these are going to be like falsy. If I look at stake, it's going to be null, right? And you're going to see that undefined and null are going to serve really similar purposes. But this actually means something to me as a developer, right? What does it mean? Do you have any idea what it means for something to be null as opposed to undefined? I'm sorry. It doesn't have a falsy value. It is falsy. I'll tell you that. I'll talk about that in a second. But anybody? It's going to be given a value at some point, right? That's okay. Getting closer.
Isn't it like intentionally left blank or something?
Yeah.
Rather than like we haven't done anything yet?
Yes, I think that's the important difference here. Like basically null and undefined for all intents and purposes are kind of the same thing, right? The difference here is that undefined is more like I didn't give it a definition or it lacks a definition, whereas null is I'm purposefully defining it as nothing. So rather than it being like technically different, there are some technical differences, but for the most part they are the same technically. Rather than there being a technical difference between undefined and null, it's actually more for the developer. It's like when you get undefined, it usually means that like you're missing something, or like you forgot something, or something else, or like, it's like usually it's just like, or it wasn't passed in, right? You'll see this like later that undefined is going to be a way to signal that like just something isn't there that's supposed to be there. Whereas null is more like intentionally left empty. It's like this is empty for now. I will eventually give it a value. Does everybody see that? It's more for the developer than for anybody else, right? Cool. You'll see me do this sometimes. Like sometimes I will do this. I will declare a variable and just set it to null. The idea is that the intention is eventually to give it a value. Whereas undefined, as we'll see, is usually like, oh, I just forgot to pass something in. Cool. Questions on that? Now, I want to talk a little bit about falsy values. I'm sure you all are familiar with like booleans. I don't think I have to go over true and false. Yeah, it's fine. Right? You know about type coercion? Like, the bang operator? Right? So if I do like not true, I should get false. And not false, I should get true. Pretty straightforward. Not true should give me true, right? And not false should give me false. This double bang operator is what we're going to use to coerce things into true-false values. And basically, I'm going to use it to show you what in JavaScript is considered true and what is considered false. Because as you learned in Ruby, there are some things that actually evaluate to false when used in logic. Can anyone name something? Nil, right? Exactly. Nil was used as like an empty. If you used nil in if statement, that always evaluates to false, right? We're gonna find that in JavaScript, there's an expanded concept of falsiness. Our first example is undefined and null. Both of these things are falsy, right? So if I were to do something like if everybody knows console log. I have to go over that. It's just like your puts from Ruby. Okay. What will a console log? Yeah. Who thinks it's going to be yip? Who thinks it's going to be nip? Just who didn't raise their hands? It should be the rest of you. Okay. It's nip. Yeah, right. It's just like it evaluates to false, basically, in this logic, right? So that's truthiness and falsiness for some of the beginnings of truthiness and falsiness. Undefined and null are both falsy, right? You can use this to your advantage. There's some cool use cases for this, but that's pretty much what like that is for. Yes?
Does the conditional like if for the ternary operator, does it actually do like the equivalent of the double bang operator and try to convert it to a boolean?
Yeah, under the hood, like it does that. Yeah. Anybody else? Questions or concerns? Is this confusing, or is that okay? Okay. So that's undefined and null. You guys know booleans. I'm not going to talk about that. Numbers are interesting. In JavaScript, in Ruby, you had two types of numbers. What were they? Integer and float. Yeah. In JavaScript, you just have number. Like integers and floats fall under number, right? They're pretty straightforward. 2, 2.34, right? These are all numbers. If you want to check the type of something, by the way, it's actually just as simple as doing type of and then whatever it is that you're checking. That's kind of weird, but undefined, right? So type of 2 is even type of 2.76 is also a number, right? Now, numbers are pretty straightforward. I don't think there's really much to be said about them. I mean, they're just numbers, right? There are some interesting things as far as like truthiness and falsiness. So principally, one of them is that like 0 is actually falsy. Whereas any other number is not falsy, is truthy, even negative numbers. Right? But 0 is considered falsy in JavaScript. Yes. So if I do this, will this console log? Yeah. Cool. Thank you for laughing. It's not really a joke. It's just dumb. Okay, everybody cool on that? Right. There's can I? I'm sorry.
I always see myself struggling why it's not working and forgetting that zero is false.
Yeah.
And some kind of love
Yeah, it's just like one of those things. So just try to remember it. It's like it's actually very useful because, for instance, I can do something like this. Oops. Like that, right? I could actually check an array's length, and if I do this, right, empty, but if I do, see that, right? Like that's like one potential use case for it. What's up? I'm sorry. It did, yeah, it's right there. Yeah. Cool. Right, there's a lot of use cases for just checking like zero. There's a reason that zero is falsy. It's like it's actually useful for checking if things are empty. There's like a variety of use cases, or if there's no value, you know, et cetera, right? But that's like one thing. I do this. Oh God. Yeah, there's an infinity. Don't worry about it. It's a very, you will never use it. Where's the other? I'll find out a different way. I was gonna show you not a number. Have you guys seen that before? Actually, I don't know. It is. Okay, well, anyway. Their only truth is infinity. Okay, anyway. Have you guys seen not a number? Not a number is a weird one. It comes up when you do some calculations that don't, like, evaluate to anything. For instance, there's some weird stuff about this. And JavaScript is a weird language. Remember, it was built in 10 days originally. So, like, not a number is type of number. It's like the most contradictory thing in the world. It's falsy, yeah. So that at least makes sense, right? It's just like not a number, so it's like falsy, right? That makes sense. But then there's some like I'm sorry. Nepa number. There's some weird things like not a number never equals not a number. It's just like weird. Yeah, you would to check you have to do isnan, like that. Oh God. Oops. Yeah, you have to do this like stupid isnan thing. But like, yeah, you can't do this. I don't know. It's weird. I'm gonna show you this video later that has like all this weird stuff that JavaScript does, like that you never really hit, but like just like it's like really absurd and like how the heck does that happen? Yeah, it's the WAT video. Yeah, it's a great video if you haven't seen it. But yeah, so not a number is a bit of a weird one. I'll show you when this comes up in a second. But everybody okay on like just numbers and just like zero being falsy, not a number also being falsy? Okay. Strings are pretty straightforward. They're strings. Again, these should be really familiar data types. Strings are true, right? Truthy, except empty string, right? That is also useful because you can check if like a value is empty, just like not. So that's also useful. Empty string is empty. You can switch. There's some stuff to talk about. You can parse like a string as an integer. Basically, it's your 2i. You guys remember 2i and 2float from Ruby? You convert a string into an integer, right? Like sometimes you have to. Right? Parse int. I think you do parse float too. Oh well, it's an integer, so it just anyway. I think actually parse float. Yeah, that works. Works fine, right? There's some interesting tidbits about this. So this is kind of funny, but like, suppose that like I had like if you put some like random gibberish here, right? You'll notice that it just evaluates that, right? basically parseInt is kind of smart. It will, if it reads numbers, it will start parsing those as an integer, and then anything after that, if it's not a number, it'll immediately just cut off and just say like that's a number, right? You might be like, why the heck does it do that? But actually, it's actually useful for doing something like this, like. See that?
What if you put some numbers after that? Because like 11 probably 12.
Yeah, it just doesn't. It just stops, right? But you can see that that could potentially be useful, right? Yeah, and it just stops when it stops reading numbers. It's just like, oh no, I'm done. If you put letters first, what do you think happens? It stops. Anybody?
But I think first it'll give you a value.
And you think it will go to the next number? Anybody else?
I don't think it'll give you a value.
It's just like, I don't know. No, it's just they don't even do anything that complicated. It's just like it's not a number. Don't even try. Yeah. So yeah, that's where like nan comes into play. This is the one consistent thing where like nan comes up. Is that okay with everybody? ParseInt.
So how would you get, suppose you get 12 from
regex is how you do it. Do you guys know what regexes are? Yeah, regular expressions. It goes beyond like individual programming languages, but maybe if we have time, we'll talk about them. But they're not. It's not a JavaScript thing. But if you wanted to, there's a whole this is like that's like a technique that like people develop over time. But I'll send you articles on regular expressions. They're very cool. I'm sorry.
No, please do.
Yeah, they're super cool. Any questions on strings? I think they operate like strings normally, basically, how they have in the past. Is that okay with everybody? Now, arrays. Actually, I'll just scroll down here. All of those things that you saw above were what we call primitive data types, meaning that they are responsible for just pure data, right? But what we actually look at when we actually look at arrays and objects is that they're actually what we call data structures. Does anybody know why they're called data structures? That's actually exactly it. You'd be surprised how many like things are like weirdly named or have like very like complex names. Or actually just like that's actually just what they do, right? So like data structures, they structure your data. They're meant to sort of represent relationships between pieces of data, right? So think about an array. What is array good at representing? Sorry? An ordered list, yeah. Let's actually even take that down, like make it even more high level. Like what exactly is an array good for? It is an ordered list, that is true. I'm sorry? Data, yes. But I would say, okay, collection of data, okay. I would say that it's good for keeping track of lists of things that are the same, like an array of integers, an array of strings, right? The idea is that like normally when you use an array, I mean, you can put multiple data types in there, but the idea is that like an array is meant to represent a collection of things that are the same type, right? It's an array of dogs. It's an array of people, right? That's what arrays are typically good for, and that's like what their main purpose is, right? So it's like the idea is that like every single one of these things is the same. They might have different data like is stored inside of them, but they're the fundamentally same type of thing, right? So they're used for collections. They're used to collect, just like imagine like a line, right? A line of people, right? If you could have a line of people and dogs, but that would be confusing and weird to deal with, right? It's better to have a line of dogs and a line of people, right? So arrays, you already know how to use them. We're going to talk about iteration later in the later lecture this afternoon. But arrays are what you know and love, right? They square brackets, nothing crazy here. Right, there's an array, right? Here's an empty array. Now, as far as truthiness and falsiness, what do you think this is? Truthy. What about this? The empty array. I just don't want it. Falsy. It's actually still truthy, right? This is something to be aware of, is that empty arrays do not evaluate to false, right? Which is why we often do something like this, right? Yeah. like check the length of the array to see if it's empty, right?
Oh,
Yeah. So keep that in mind, is that like empty arrays will still evaluate to true. This will not work. Yes, that's actually true. That is actually right. The array is, I'm going to talk about this in a second, but the idea is that like the array occupies a space in memory, and therefore has a value. It is not like an empty value. So it is truthy. It is there.
so does that seem full?
Yes, we're going to see that in a second.
If you assign a variable to an empty array and you like, you call it, or you say like the array at 0, would you get
Yep. Right. So if I do, right, this is the old arrays that you know and love, right? Right. Now, what do you think happens if I access index 3? Yeah. So in JavaScript, when you access an index that isn't in your array, in this case, there's no index 3, what ends up happening is that it just returns undefined. It's just not there, right? So that's useful. What's that?
What would happen
I think it errors out. I forget. Does it error out if you try to access an index not in an array? Oh, does it loop around? Oh, I forget. God, what is it called?
it only does that for like
Load faster art.
yeah, I'm looking for it.
Oh, okay, it's the same. Okay, it's just like nil. Okay, so I guess it's the same. So yeah, it just doesn't return anything, right? If you try to access a value that's not in your array, just nothing, right? That's pretty easy, right? It's pretty straightforward. That's how arrays work. Let's see. One of the things that you're going to find interesting, and this is actually going to apply, as we're going to find out, if you look at type of array, what do you think its type of is? Okay, you guys know this. Okay, cool. So arrays are objects, right? Now what I'm going to say the rule of thumb in JavaScript is that all objects are what we're going to call pass by reference. Now you're not going to know what that means. I'm going to explain what that is right now, but the rule is that all objects are pass by reference. Okay? Now to explain what exactly that means, consider this. If I do var a equals 2, and then I say var b equals a, right? If I look at a, it should be 2. If I look at b, it should be 2. Now, if I modify b, I say b equals b times 2, something like that, what should b equal to? What should b be equal to? God, that was weird. Yeah. What about a? Good. This is what we call pass by value, right? The idea is that like when I did this, b equals a, only the value that was stored in a was stored in b. Therefore, modifying b did not modify a, right? It's the value, not like a reference to that function, to that number, right? So I can modify b freely, and I can modify a freely, and they will not affect each other. However, arrays are a little bit different. Var a equals 1, 2, 3, and var b equals a. So again, if I look at a, if I look at b, same thing. Now, the tricky thing is that if I push something into b, and I look at b, it's as expected, it's been affected, right? Nothing crazy, nothing unexpected there. But if I look at a, it's also affected. The way I like to think about this is like, this is what we call pass by reference. The idea is that at the time that we assigned b to a, what was really given to b was a reference to a location in memory. So a was pointing to this array, which is located somewhere in your machine, like somewhere in your machine. And the idea is that the reference to that array is actually what's stored in a. Now, every time you use a, it's like you don't do the work on the reference, the array just comes out for you. But the idea is that like when you assign another variable to a, what ends up happening is that you only gain the reference to that array, meaning that if you modify B, you are modifying the same array that A is pointing to, right?
So, like, here, no like actual data or value is being like assigned when we pass like objects defining objects.
Mhm.
None of it is like actual values or data being stored.
Yeah.
You're saying that it's like wherever the location
In memory, yeah.
in memory.
Technically speaking, what's actually there is a value that is passed, but it's the location in memory. That's what's actually being passed. But like, yeah, none of this data is being passed.
1, 2, 3 is nowhere in
No.
A.
No, it's not in A.
What we're defining is where A is.
Yes, right. That's actually what A is actually what it stores. What is really stored in A is a pointer in memory that says where that array is. And so every time like I said B equals A, it's actually saying, oh, it's the same pointer, but it's not the array that's copied over, right? To give it like a real life example of this, like imagine you have a bookshelf like full of books, right? Are you gonna carry that bookshelf around and give it to you whenever someone needs books? No, right? You're gonna leave it in a corner somewhere, like in your house or like right there, and you'll just say like, "Hey, dude, if you need a book, it's over there in that bookshelf over there," right? Now the idea is that like if someone comes over and changes the bookshelf, like takes some books out or puts some in, then when person B goes over there to look at it, they're going to see that it's been modified. But also when I go over there to look at it, it's also going to be modified, right? They're pointing to the same bookshelf. If that makes sense, right? It's a reference to where it is. What's that?
So is that like an intentional feature?
Yes, it's very much intentional. There's a reason for that.
You're pointing to the reference of what something is, not the actual thing of whatever the thing is. Right?
Yes, yeah, yes.
Is that how JavaScript can reload pages and like point to things that are not actually the things?
Yes, that's actually part of it, right? So this is actually like a purposeful like thing that they kept in. It's like they could have made it pass by value so that like when you assign B to A, that it's actually like a different array. But they actually kept it in because like actually having the reference to the same object, it actually has some powerful benefits. Namely that like you can like store a variable and just like modify it in XYZ number of places. And as we're going to see that's going to serve us particularly well when we start modifying what we call the DOM, like the actual web page, right? So keep that in mind is that is actually an intentional feature. It is not something meant to like confuse you or is like a bug. It's actually like intentionally there, right? Questions about that? We're still going to explore this a little bit more. So as kind of a pop quiz question, what do you think this, if I finish this, what do you think it will yield? True? False? Who thinks true? Who thinks false? Why?
Because where you store one empty array is not the same place where you store the other.
Yes. They're entirely different arrays, right? It's not their contents that are being compared, right? It's actually their location in memory, and they're actually different locations in memory. I declared one array here, and I declared another one there, and they're actually completely different arrays. What's up?
So does two empty arrays by non-strings equality equal true?
No. They're actually just different arrays.
So an array with one and another array with one.
Yep. Contents are not compared. What's up?
But this is only for like data structures, right?
Yes, objects.
Like only because where you store a data structure is going to store the memory of where that thing is, whereas like 2 is 2 is 2 is 2. Right?
Yes, exactly. That's right. That's exactly right. So this only applies to objects, right? So all your primitive data types are fine. Strings, you can still do regular comparison. Like undefined, null, all those things are still fine. All the primitive data types, booleans, obviously, numbers, those are all fine. But objects are a little bit different because they actually point to locations in memory, not like the contents. What's that?
So is there a nice easy way to compare contents of objects, or do
You
you have to iterate?
have to iterate. Yes. There are specialized functions that do it, but it's like they end up just doing under the hood some sort of iteration. But the thing is, like even in Ruby, like you could do that in Ruby. Like you could do, like think like array 1 2 3 does equal array 1 2 3. Oh. Oh God. This is true, right? But it's only because Ruby is nice to you. It actually doesn't have to do this for you. No other language really does this. The interesting thing is that Ruby is just like, do you guys know the creator of Ruby? It's like Matt's, his whole philosophy of like Ruby. Yeah, he wants to be like a happy programmers, right? So like this is actually something that they built in for you, not that is like but it's actually not like normally how these things work in actual other coding languages. There's just like a Ruby thing. I don't even know if Python does it, but like lower level languages, this would just not fly, right? Cool. Cool on that, right? So this is there's some interesting consequences there, right? This means that like, well, actually, let me go back to this. So like, var, look at the a equals 1, 2, 3. Var b equals a. Is b equal to a? It is, because it's the same array, right? It's the same array. That's why when I said b equals a, right, they are the same exact array. Good. What's up? Symbols? They're also primitive, so those can be, they're not objects. So I believe that you can compare them.
Yeah, but I mean, like, some symbols point to the same, like, ID, or at least in Ruby, I'm not sure.
I don't know. That I would have to look up. I'm not sure entirely. But I don't even know how to make a symbol. Make symbol JS. I actually don't know. I just like never use it. Okay, let's try it. Just change this to bar. All right, symbol 1. Okay, so symbol. What the? I can't type. That's weird. I've never seen that before. But okay, let's see. So symbol. Let's say like var b equals symbol 1. Is b. Actually, I don't even know how to change this thing. B should be equal to symbol 1. I think that should definitely be true. But let's see if I make another symbol. With the same thing, right? Who thinks that these are going to be equal? I actually don't even know the answer to this. Who thinks symbol 1 will be equal to symbol 2? I don't know. Yeah, I guess because it's like, I guess it's a bit like a new instance, right? We'll talk about that. We'll talk about this later, but yeah, okay. I didn't know this. Sure. We don't really use symbols. That's why I'm just like, okay. Questions on that? Pass by reference? No? Okay. So again, the main bit is that like, be careful about how like the values for your arrays, right? We're going to find that sometimes it's actually convenient in the sense that you can modify the same object. You can, as we'll see also with objects, you can modify them in one place and it will change the value somewhere else, right? Which is useful sometimes. Other times it's a pain because like you actually intended those to be different. And there are workarounds around it, like copying your objects, copying your arrays. But those we'll see later, right? But just keep in mind for now that like that's what pass by reference is, right? Is everybody okay so far? Okay. The last big data type that we're going to talk about are objects. So objects are just what you call in Ruby called hashes. We just in JavaScript call them objects. So they're pretty straightforward, like that. These can be like right, pretty straightforward. If I do object.beef now, this, is that okay? That should be still familiar to everybody from like hashes from Ruby, like still operating fundamentally the same. One nice thing is that in JavaScript you can do this, right? That's a lot nicer to write, right? But yeah, objects they're used for similar purpose. Also a data structure. It's a data structure that, unlike arrays, well, number one, it's unordered, right? There's no order to the particular keys. And it's best used for representing like things, like collections of attributes, right? And they could be a variety of different types. So you can imagine that like var person might have something like a name, so it's like blah blah blah, and some sort of like the age, and then like I don't know, I'm sorry, address, et cetera, right? But the idea is that like, sorry, I messed that up. But the idea is that like, you know, this is the objects, they work exactly as they did before, right? They're used as collections of attributes that represent a single thing, right? So this object, if I had written it properly, would have actually been like a person object, and it would have had all the data about a person. Cool. Now, there's some cool things about objects. It's also, as I mentioned earlier, all objects are passed by reference. So again, if I do like, let's say, let me redo this. Like that, right? And I say var b equals object. Look at b, and then I do b dot lettuce equals yuck. I don't know, right? And I look at b, obviously new key value pair. But if I look at object, it's been modified as well, right? Because it's been passed by referenced. Okay. So everybody, does that still ring true for everybody from the previous example, right? So modifying b is also modifying object. Questions on that? Yeah. Okay. Yeah. Was there anything I missed here? Any fun stuff? No? Any questions on that? I think it follows the same pattern as. One thing I will mention is that technically, as I mentioned earlier, type of an array is object. So there's only really one way to check if something is an array. There's a method called isArray attached to the array class, which is how you check. But yeah, this could be like, that's like one thing, is that like technically all arrays are objects. Oops. So like, you know, like you can't really distinguish them this way. You have to do something like array is array. Yeah.
It just has a class, like JavaScript just has a class array, right? So you can always call on something.
Yeah. All these things actually have classes like number, string. They all have classes that just like exist, and they're like methods on them. For this, I won't go over. There's obviously a ton of methods on these, but like, you know, the classes are just there for you to kind of like, if you want to mess around with or you want to look at. So.
Can an object be falsy?
Oh, no. The answer to that is no. Yeah, it's just like no, it can't.
Yeah.
It's always true. Even empty objects are considered truthy. Questions? That's fine. Yeah. Yes.
Do you have a preferred documentation for JavaScript?
MDN is good. Yeah. Yeah, MDN is great. I think it's like, it's probably the most it's usually the most up to date. It has a ton of stuff. It's pretty clear. They have like examples and stuff. I think so. I'm sorry.
It's the one reference on the
Yeah. It's like yeah. Everyone uses this. It's very, very common. Yeah. Other questions? So what we're actually going to talk about in the next lecture, kind of as a preview of this, is functions. Right? Now, I'm sure some people have already kind of expressed some like weirdness about this. Right? Functions, right? So you have functions like. We've seen, some of you have already expressed that, like, have you seen that you can store them in variables? Yeah. This is going to be, like, the next lecture is going to be very, like, it's going to introduce you to how this is really where JavaScript deviates a lot from, like, Ruby as a programming language. It actually follows an entirely different paradigm of programming called functional programming. And we'll see why exactly it follows that paradigm and how does it do it. But the next lecture is going to is where it gets, like, interesting. So one example of why this is weird. What do you think the type of this thing is? Yeah, it's an object. Oh, well, it's a function, but as you're going to see later, this is also an instance of an object, and we're going to see that that's going to be weird. This is actually, function is actually a subclass of object, but it is also an object, and we're going to see like, why is that weird? Like, what the heck is up with that? And like, but also why is that powerful? Because we're actually going to see some really interesting abilities for functions that we just did not have in Ruby. We're gonna do some like fun stuff, right? So that will be later's lecture. That will be the later lecture, and basically that will be all the fundamentals we'll cover. By tomorrow, we'll start looking at like some weird fun stuff. So actually, I'll give you a preview of that. It's like what we'll be doing tomorrow, just early, just because I think it's like funny. But like this is actually something I wrote to kind of mess with somebody. So this is JavaScript. By the end of tomorrow, you will know what all this does, right? But take a look at that. If I click now on this page, it loads a Boston Market commercial wherever you click. So yeah, you can do some like weird crap with this. But that's actually basically by tomorrow we should be able to talk about like, even if you can't do it yourself, you should be able to recognize all this code. But that's actually what we're building up to. Today is all about like, you'll notice here that like, I'll write this here. Like, if you don't like the fact that functions can be passed around, then you will not like this like awesome functionality that it gives us, right? So we're going to talk about that later. Today, that's actually going to be the main thing, is talking about like how do functions work in JavaScript, what makes them powerful, and then just like getting used to that, like this whole functional programming paradigm, this ability to pass around functions. Cool. All right. Thank you. You guys are awesome.